Okay, here we are at what I would consider the very last little piece of your factoring checklist. And just as a quick review, I don't remember any of it. If we're factoring, what do we start with? GCF. And if there is, cool. If there isn't, cool. We then go to binomials, and we hope to see the difference of two squares. Awesome. A squared minus b squared. And that's a good sign because it factors nicely. If it's not, we check a what, Kian? So we're into trinomials, so I'm cool with that. You might check perfect square trinomial first. Cool. What if it didn't work? You hope, what about the leading coefficient? You hope it's a 1, because if it's a 1, there's a shortcut waiting, maybe. If there is not a shortcut, you have to multiply the first and the last, and you rewrite it, and we use what is called grouping, right? Now, if we look at these, there's some problems that don't group. And whether or not we hit that super hard, turns out pretty much every problem that you've done the last 3 days of class has been one that doesn't group. It's why we are completing the square, to be able to solve these equations. The good news is that when we complete the square, do we always do the same thing? Make the leading coefficient 1, divide b by 2, square it. Like, we always do that same process, right? Every time it's the same. Because every time it's the same, it means that today, I'm not going to name this yet. We're going to start right off with a new math word that I'm not sure if you've ever seen it. Have you guys ever seen derive? It is not a derivative, if you know that word. It's not the same thing. To derive something is just to see where it comes from. So there's an idea in calculus that's called a derivative. This is not the same thing. We are not doing calculus. We're just going to see where this comes from. And the what that we're going to check out is derive the quadratic formula. Okay. We are deriving the quadratic formula. And what this is a way to solve equations, whether they can be factored nicely or not. It's a single equation that we just plug values into, and we get the x-intercepts, the roots, the solutions. And it all stems from this idea of completing the square that we've been working on. We're going to do a really ugly looking completing the square with the understanding that it's nothing different than what we've done before. We just don't have concrete numbers. So here we go. I want us, and it's not even going to feel like an example because we're just doing the derivation. We're deriving it right now. But consider the following. We're going to solve this quadratic. Ax squared plus bx plus c. And if we're solving it, we're going to set it equal to what? 0. Okay. Right off the bat, this is the exact form that all the problems that we've been working through have been in. Whether the c was here or on the other side and we had to complete the square to make it work, they've all could have been written like this if we've ever, any equation that we solved. You can arrange it like this, something x squared, something x, and a constant. Okay, right now, we're going to break this down into some smaller pieces. Can I make it so that only the x terms are on one side? Only things with x in it. Okay, and I'm going to try my best to change colors every time. And again, you do not have to replicate this, but you guys are going to help me. I want to isolate the x variables. Isolate the x terms. How do I make it? Is there any obvious thing that I can do to make it so that only x stuff is on one side? Everybody cool with subtracting c? Okay, let's do that. I think that leads me to ax squared plus bx equals negative c. Okay, now normally when we do this with problems, like real true problems, we leave an awkward gap here. I've left it out here. I'm going to complete the square on this side, but we're not quite there yet. Currently, what is the leading coefficient on the left side of this equation? It's an a. What do I want it to be? So what should I divide everything by? Now, whether we divide everything by a or we factor it out and then divide it, they're the same thing. I'm going to make the leading coefficient 1. So divide everything by a. And up to you if you want to write all these annotations to get leading coefficient equal to 1. Now, when I say everything, I could have said both sides, right? Both sides of the equal sign. Everything is more encompassing, I believe. If I take this whole side and each piece gets divided by a, what's ax squared divided by a? X squared. What's bx divided by a? So I could write it as bx over a. Can I just write b over a x? Okay? Equals, if I divided everything on the left by a, everything on the right must have got divided by a as well. Negative c over a. Super important. If we get questions, ask them right then and there, immediately. Cool. Everybody cool so far? We've made our leading coefficient 1. We now have an ax squared plus something x equals something. Okay. Right now, we're at an opportune time to make this thing perfect. And when I say that, it's really just a way to kind of skirt around saying, let's complete the square. Now, we are completing the square. It happens on the left side to get our perfect square trinomial. And remind me, what do we add? You take the number connected to x, which in this case is b over a, so it's kind of ugly, but it's still connected to x, and then we do what with it? How do we complete a square? You take this number, you divide it by 2, and then we do what? Square it. Now, I don't know about you guys, before you commit to writing this, I'm going to write it once, and I'm hopeful that we can all agree that there's a better way to write it. Anybody look at this and say, oh, yes, I'm psyched. I love that. No. Okay? So, me neither. Instead of dividing by 2, is there an easier way that we could view that operation? So, I'm not going to multiply by 0.5, but can I multiply by 1/2? They're the same thing. Is multiplying by 1/2 the same as dividing by 2? Like, check this out. What's $1 divided by 2? Or 100 divided by 2? What's half of 100? Okay, they're the same thing. I'm convinced. Instead of dividing by 2, which that's really what we're doing, it's much easier if we think about it as multiplying by 1/2. Okay, and I think I gave you guys the same advice when we were doing fraction problems, but I'm just re-emphasizing. So we're going to take smaller steps. This, if we do the inside, do you agree it's b over 2a? And I've just multiplied straight through and straight through. And what still has to happen to this? Do what? Louder, I think you said it. Squared. Okay, one more little line of scratch work here. If we take this and square it, what's the numerator become? And just to be really clear, this is what we're doing, right? This is what it means to square something. What's b times b? Okay. Over, what do you guys get for the denominator? 4, because 2 times 2, and then a times a is a squared. Everybody's still on board. Now it's uglier because we don't have numbers, but can you tell we're doing the exact same thing? Just a little bit more work because there's no numbers. Okay, I'm going to add this to which side? Are we messing with one side or are we kind of dealing with both? Both sides. The only reason I'm asking is because we either have the option of add a 0 or add it to both sides. And this is a both sides situation because we're not trying to keep one side anything. Okay, so here we go. I'm going to add this b squared over 4a squared to both sides of this equation. And I'm only going to keep blue in here. So here we go. X squared plus b over a x plus b squared over 4a squared. I just added it right here. Equals, and I'm going to put this one first. And I know it feels weird, but we're going to. B squared over 4a squared minus c over a. Is it the order?
No.
Okay. So I'm using, is this blue different?
No.
So no, you're okay. You might have wanted, and I'm happy to change it. Do you color code yours?
No.
Okay, and that's okay whether you do or don't. Is this what you were hoping to see instead?
No, I just didn't know why the equation was.
So and I think I get what you're asking, but correct me if I'm wrong. I'm using the red to show that here's my step, and I don't know why I point to it with the blue arrow, and then the actual work is in blue. So the blue, this part is like the actual work we're doing. This is just like my annotations to say, here's the steps that we're following. Okay. All right. Now, two things that I notice, and we're going to deal with both of them right here. What was the point of adding this to the left side? What did we just make? Desi says a PST. We just completed the square, right? We've made it a perfect square trinomial. Do they factor nicely? Yeah, and it might not look like it's going to, but I assure you it factors the exact same as all the other ones. Do you know the square root? And I'm going to annotate this first. I'm going to do two things in this step. On this one, we're going to PST, the perfect square trinomial, factor on left. So we're going to factor this trinomial that we just found. But then at the same time, this bothers me. If I wanted to add these or subtract them, which is what's written, can I do it yet with this line right here? What do they need to be able to actually combine? Not a square. If you want to add two fractions, they have to have, and I'm going to find a common denominator on the right. Now, just to make things look a little bit nicer. So because these steps aren't going to mix with each other, I think we can just probably do them in one line. Let's factor this side first. How do you factor a perfect square trinomial? Okay, so I'll take the square root of the first term, which is x. And then this one, I just want to stress, it might be hard to see, but we're going to clean it up. Do you guys know the square root of b squared over 4a squared? So b2a, I'm going to clean that up a little bit. Do you guys agree that this is what we just squared? So if that's what we just squared, then the square root must be this. And I can see it. It's b over 2a. If you don't see the connection there and you want to see it the other way, what's the square root of b squared? What's the square root of 4? And what's the square root of a squared? A. What's the sign in between them? So the left side factors exactly like this. And it's ugly, but it's the same thing that we've been doing. Square root of the first, square root of the third, use the sign in the middle. Have I lost anybody yet? Okay. On this one, can you guys tell me what the common denominator should be? Like this has 1a, and this has 1a. This actually has a and 4, right? What does this one need? It needs a 4 and one more a. Do we all agree with that? Okay, this one, I'm going to try to save a line, just so we can do it here. If I want to multiply by any choice of 1, can I? Yeah. Kian suggested that we use a 4a right here. If I do it down here, but I want this number in pink to be a 1, what has to be up top? 4a. This is just me finding the common denominator. Okay, I'm going to clean up this right side a little bit because I see that it's going to be b squared over 4a squared minus 4ac over 4a squared. Like they match already. I'm going to shove them together in one fraction. In this one, if you're going to get lost in this problem, I assume it's going to happen right here. So I want you to make sure you're really, really clear if you don't understand what just happened. This does not feel like the hardest problem we've done in this class. It did first hour. It's not easy. Questions before we keep kicking, though. Nope, we're not. We're going to keep going. But I'm just pausing to make sure that if anybody has issues here, I give an extra time for you to voice those issues before we continue. Don't say Declan is a huge nerd. That's not nice. All right. We're trying to solve for x. Like, that's our goal here. We want a way to avoid having to do all the completing the square stuff. So we'll just complete the most general square, and we'll just see if a formula spits out for us. If I want to keep solving for x, I don't know that I need to keep annotating, but gosh, right now, if I tried, it's stuck inside of a square. Shucks. Let me make that sound like a question rather than just a hint at stuff. How do you undo a square? Okay. Did you guys know that that's what I was asking for? Okay. So this last step, I'm just going to say solve for x. And it's going to take a few lines, but I don't want to have to say a new line every time we're doing the exact same thing. Okay. So I'm going to take the square root of each, and it's entirely up to you in your notes, but because you may watch this video again later, I'm going to rewrite the whole expression, and I'm going to actually show me taking the square root. I'll put a square root symbol here, and I'll put one here, but notice where I started, it's like I left room for something. This is just a number, because these are just the A, B, and C of my thing, plus or minus. Okay. So, kicking forward. On the left side, my square root symbol, my radical, and my square just undid each other. And over here I have plus or minus. And then before we commit to just rewriting the same line, let's look. We cannot do the square root of a difference. It doesn't work the way you want it to. Somebody's going to try to say that this is b minus 2 something. It's not true. We can see it's not true, and it's really easy to convince you of that with some numbers, but I'll do that here in a second. I don't know the square root of the numerator. It's just the square root of b squared minus 4ac. I can't do anything. Do you know that square root, though, of 4a squared? What is it? 2a. It's just the square root of 4 and the square root of a squared, which means on this side, I'm going to rewrite this as plus or minus the square root of b squared minus 4ac. And we took the square root of the bottom piece. And remind me one more time, what was the square root of the bottom? Square root of 4 is 2. The square root of the a squared is a. Okay. Is there anybody in class, I guess it'd have to be in class, why would I specify that? Obviously it's in class, that doesn't agree with this? Anybody's gut feeling is that? Or something similar to that? Yep, so like that's a natural thing to try, and I just want to demonstrate, and whether we need it or not, I'm not sure, but you guys are hard to read sometimes. Do you guys know the square root of 9? Do you know the square root of 4? Okay, so if that property worked this way, let's just try this. If you try to do it that way, you're going to say that this is 1. Do you, like, we agree if you try to do the square root of this minus the square root of that, you're going to get 1, because 3 minus 2. But if we just take a step and just clean up what's inside of our grouping that we don't normally show, this is really the square root of what number? 5. Is the square root of 5 1? No. Definitely not, right? Square root of 5 is not 1, which means we can't split this up. And this is just a convincing you of that if you're just trusting me blindly. Like, we can see it doesn't work just by doing one quick problem. Okay, well, there's something awesome. We're going to solve this for x right now. And right now, I don't have to worry because they're both fractions, but what do we notice about their denominators? Well, that's incredibly convenient. Cool. How should I solve for x if we want to go one more step? Ooh, I don't want to multiply. Why? So walk me through this real quick, Ian. I'm going to pick on you. Hopefully not in a mean way. What are we trying to solve for? If I multiplied by 2a on each side, did I make my x term simpler or harder? Yep, so it wouldn't take us in the right direction. Instead, if I only want x on this side, what could I take away from each? So I'm going to do negative b over 2a, and I'm going to take two lines here, plus or minus the square root of b squared minus 4ac over 2a as well, right? Okay. Big moment coming up. You guys ready to do a little singing with me? Good. It is exactly what RJ was talking about, what I've alluded to a couple times. If these have the same denominator, can I write it easier? Yeah. I'm going to put some stars here, and we'll define this here in just a minute. Important stuff right here. I'm just going to shove these together. If they already have the same denominator, I think I can just say x equals negative b plus or minus the square root of b squared minus 4ac all over what? 2a. Boom. This is your new out if you need one. This right here is incredibly powerful, and I almost have goosebumps just from what just happened because you guys didn't seem to have a lot of, like, I wish I were kidding, or I'm psyched that I'm not kidding. Probably the second one more than the first, realistically. But you guys didn't seem as bothered by this whole process. It's ugly, right? But it's the exact same thing that we've been doing. It's just uglier because we don't have numbers. What we have just found is the quadratic formula. And for real, there are the goosebumps, just for the record. As we look at this, the reason that we just spent 20 minutes, roughly, doing this problem is, you probably do. We're going to define this one more time. You are not going to have homework this weekend, but on Monday, just a heads up, I'm not going to be here. Do you want, I lied, I'm not even going to offer, I'm just going to make you a video and say, hey, here's a bunch of problems. Let's do a couple together, try them, and then I'll work a few more that you guys can resume if we need more examples. Cool. So the quadratic formula. Now, earlier I alluded that this might just get us out of factoring, and kind of. But we're going to write this out. We got 30 seconds. We're golden. Given a function that takes the form f of x or y equals ax squared plus bx plus c, which is like every quadratic ever. The roots, or if you want to put them all, we could say the x-intercepts, the solutions, or the zeros, are given, or I'm going to say are found, so I don't use that word twice, at, and here we are. Turns out that if you want to find the roots of something, but you don't want to factor, or you can't factor, you can always just take this equation, which has numbers here, here, and here, and you can plug it in. And it's always going to be x, the root, is equal to x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully it's less depressing when you hear it in your heads. We will see, we'll have time to do a bunch of examples of this on Monday. Appreciate you guys. Peace out.